Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for May-June 2023 variant 1. So let's get started. Question 1 says, which vector diagram correctly shows the force Z as the resultant of forces X and Y? So we can either use head-to-tail method or parallelogram method. If we're drawing the arrows tail to tail, that means that we have to continue the diagram as a parallelogram, which means A and B cannot be correct. For C, there is X and Y head to tail, starting from this point and ending at this point, but Z is pointing in the opposite direction. So the answer is D, where the start from X then Y to the end is the same as the start and end for Z. Question 2 says an object falls towards the surface of the Earth. The object is falling at its terminal velocity. Terminal velocity means constant speed. Which statement is correct? There is air resistance and the acceleration of the object is negative. No, there is no acceleration. There is air resistance and the acceleration of the object is 0. That is correct. So the answer is B. Question 3 says the graph represents the motion of a vehicle. What is the distance traveled by the vehicle in 400 seconds? So the distance from a speed time graph is the area under the graph, which is the shape of a triangle. So we calculate half by base, which is 400, by height, which is 20. The answer is 4,000 meters. So it's C. Question 4 says, on the Earth, a spring stretches by 5 centimeters when a mass of 3 kilograms is suspended from one end. The gravitational field strength on the Moon is 1/6 that of Earth. Which mass on the Moon would stretch the spring by the same extension? So for the same extension we need the same force, and in this case the force is equal to the weight. So weight is equal to mg. Now g is divided by 6. For the same weight we need to multiply the mass by 6. So 3 kilograms multiplied by 6, that gives an answer of 18. So it's D. Question 5 says, a shopkeeper pours rice into a dish that hangs from a spring balance. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just the pasta in the dish is the same as it was with just the rice in the dish. Which quantity must be the same? It's technically the weight. So the weight is available here, so the answer is D, and it's also same mass. Question 6 says, a student determines the density of an irregularly shaped stone. The stone is slowly lowered into a measuring cylinder, partly filled with water. Which other apparatus does the student need to calculate the density of the irregularly shaped stone? So we can use the measuring cylinder to calculate the volume. All we need now is the mass, so we only need a balance. So the answer is A. Question 7 says, a train is traveling horizontally in a straight line. A book is on a table in the train. The diagram shows all the forces acting on the book. So we have the weight and the contact normal force, and there is a frictional force forward, but there is nothing backwards. How is the train moving? Is it accelerating? Yes, it is accelerating because there is a resultant force on the right side, not uniform speed. So it is accelerating to the right since the resultant force is to the right. So the answer is B. Question 8 says the diagrams show 4 beams, each of negligible weight and freely pivoted. Which beam is not in equilibrium? So we have to calculate the clockwise moments and the anti-clockwise moments in each case. So for A, the clockwise moment is equal 6 multiplied by 1, so it's 6 Newton meter. And the anti-clockwise moment is 3 multiplied by 2, which is 6 Newton meter. So this is balanced, so it's not A. In B, we have clockwise moment 6 multiplied by 2, that's 12 Newton meters, and on the other side it's the same, so it's 12 Newton meters also, so it's not B. For C, the clockwise moment is 3 multiplied by 2, so we have 6 Newton meters on the clockwise side. And on the other side we have 3 multiplied by 1, that gives 3 Newton meter, which is less than 6 Newton meters, so the answer is C. This one is not in equilibrium. Question 9 says an object of mass 1.2 kilograms is moving with a velocity of 2 meters per second. When it is acted on by a force of 4 newtons, the velocity of the object increases to 5 meters per second in the same direction. For which period of time does the force act on the object? We can use the equation force equals the rate of change of momentum, or force multiplied by time is equal to the change in momentum, making the time subject. It's a change in momentum, which is m multiplied by v minus u, change in velocity, over the force. Then we substitute. We have the mass 1.2, the final velocity was 5, the initial velocity was 2, and the force was 4 newtons. This gives an answer of 0.90 seconds, so it's A. Question 10 says, which row about the change of energy in the energy store must be correct? For different process, we have energy store and the change in the energy store. So water pumped up to a high altitude, gravitational potential energy of water increases. Yes, that is correct. Water pumped up to a high altitude, kinetic energy of the water decreases. No, not necessarily. Air passes through a wind turbine, gravitational potential energy of the air. No, unless the turbine is facing upwards or downwards. Air passing through a wind turbine, kinetic energy of the air increases. It should decrease since it hit the turbine, so this is wrong also. So the answer is A. Question 11 says, a woman of mass 50 kilograms has 81 joules of kinetic energy. What is her speed? So we have the equation for kinetic energy equals half mv squared. Then we substitute 81 is equal to half multiplied by the mass, which is 50, multiplied by the speed, which is required. So we have 81 multiplied by 2, then we divide by 50. Then we get the square root of that to calculate the speed, not the speed squared. We get 1.8 meters per second, so the answer is C. Question 12 says, a child runs up a set of stairs 4 times. The time taken for each run is recorded. Which time is measured when the child's useful power is the greatest? So it is the shortest time. So the answer is A. Question 13 says, a dam holds water in a reservoir. The height of the water in the reservoir is 15 meters. The density of the water is 1000 kilograms per meter cubed. What is the pressure due to the water at the bottom of the dam? We have the equation pressure equals rho GH. So we have the density 1000, G is 9.8, and H is the depth 15. The answer is 147,000, which is approximately 150,000, so the answer is D. Question 14 says, a student uses a microscope to observe pollen moving on the surface of water. Which statement describes the reason for this movement? Water molecules are moved by microscopic pollen particles. No. Water molecules are moved by pollen molecules. No. Microscopic pollen particles are moved by water molecules. That is correct. Pollen molecules are moved by water molecules. No, not molecules. It is particles. So the answer is C. Question 15 says, which statement about evaporation of water are correct? Evaporation causes the remaining liquid to cool. That is correct. During evaporation, the more energetic particles escape from the surface. That is also correct. Evaporation only happens at 100 degrees Celsius. No, that's boiling of water, only water. So only 1 and 2 are correct. So the answer is B. Question 16 says, some hot water is sealed inside a metal can. The can is in a vacuum in outer space. The hot water slowly cools down. How does the thermal energy escape into space? So through the metal can we have conduction, then in vacuum only radiation can travel, so it's radiation after conduction, so the answer is B. Question 17 says, the diagrams show graphs of displacement against time for 4 waves. All the graphs are drawn to the same scale. Which wave has the largest amplitude and the highest frequency? Largest amplitude, we have the maximum distance on the y-axis, and the largest frequency means the largest number of waves, so it's A. Question 18 says, the diagram shows a ray of light entering a glass block. Which calculation gives a refractive index of the glass? So we have sine the angle in the air over sine the angle in the medium, but the angle is always measured from the normal. So we need this angle, which is 40, not 50, 90 minus 50, divided by sine the angle from the normal, which is 25 on the other side. So the answer is A. Question 19 says, an object O is placed at point P near to a thin converging lens. The diagram shows three rays from the top of O passing through the lens. Each point F is one focal length from the center of the lens. Each point 2F is two focal lengths from the center of the lens. The object O is moved to point Q, so the distance decreases, but we haven't reached the point F yet. After point F, the image becomes virtual and upright. Which type of image is produced when object O is at point Q? So it is still real, it will be inverted, not upright, not the same size. Moving forward or towards the lens makes the image appear larger, so it will be enlarged, not the same size as the object. Same size as the object happens at distance 2F, so the answer is B. Question 20 says, which diagram shows the dispersion of white light by a glass prism? We have red and violet rays. Dispersion happens 2 times, so it's not like this. A is wrong. Red deflects less than violet, so B is actually the correct one. And the rays do not move parallel to each other after the prism, so C and D are rejected. Question 21 says, visible light has wavelength in the range of 4 times 10 to the power negative 7 meters to 7 times 10 to the power negative 7 meters. What is the range of the frequencies of visible light? So frequency is equal to speed divided by the wavelength. So we do that 2 times, 3 times 10 to the power of 8, speed of light, divided by 4 times 10 to the power of negative 7. That gives an answer of 7.5 times 10 to the power of 14. And we do it for the other wavelength, 3 times 10 to the power of 8 divided by 7 times 10 to the power of negative 7. That gives an approximate answer of 4.3 times 10 to the power of 14. So the answer is D. Question 22 says, student X fires a starting pistol which produces smoke and sound. Student Y is standing 100 meters away and sees the smoke the instant it is produced. The speed of sound in air is 340 meters per second. What is the time delay between student Y seeing the smoke and hearing the sound? Technically, it is the time for the sound to reach the student. Time is equal to distance divided by speed, since sound travels at constant speed in the same medium. So we have 100 meters as distance and 340 as the speed. That gives an answer of 0.294 and so on. So the closest one is A. Question 23 says, an unmagnetized piece of soft iron is placed close to a strong permanent magnet as shown. What is the induced polarity of end X of the soft iron, and in which direction does the magnetic force act on the soft iron? So magnetizing by induction creates the opposite pole, so it is an S pole, and opposite poles attract, so it will move to the left. So the answer is C. Question 24 says, a plastic rod is rubbed with a cloth. The rod and the cloth both become charged. As electrons move between them, the rod becomes negatively charged. So the rod gains electrons and the cloth loses electrons. So we see the movement of electrons. It should be from the cloth to the rod. So it's either B or D. But the cloth becomes positively charged, so it's not D. So the answer is B. Question 25 says, a wire has a uniform circular cross-sectional area. Which statement is correct? The resistance of the wire is directly proportional to its cross-sectional area and inversely proportional to its diameter. It's not inversely proportional to the diameter, and it's not directly proportional to the area. The resistance of the wire is directly proportional to its cross-sectional area, also not correct. The resistance of the wire is directly proportional to its length, that is correct, and inversely proportional to its cross-sectional area, that is also correct. So the answer is C. Question 26 says, the diagram shows the current voltage graph for a metal wire. What can be deduced from the graph? It's an ohmic conductor because it obeys Ohm's law. It's a straight line through the origin. And Ohm's law states that voltage is proportional to current when the temperature is constant. So any talk of temperature changing is not accepted. As voltage increases, the resistance of the wire increases. When temperature is constant, the resistance does not change. So the answer is D. As voltage increases, the resistance of the wire remains constant. Question 27 says a battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.40 ampere in the circuit and the battery supplies a total of 48 joules of energy. Which row gives the charge that passes and the electromotive force of the battery? So charge is equal to IT. So we have the current 0.40, then we multiply by the time in seconds, which is 60. That gives a charge of 24. Then we can use the definition for potential difference, energy divided by charge. So we have the energy from the question, it's equal to 48. Then we divide by the charge we calculated, which is 24. We get an answer of 2. So the answer is C. Question 28 says a circuit diagram shows two identical lamps connected in parallel to a cell. 3 ammeters X, Y, and Z are also connected in the circuit as shown. Which statement about the current in X is correct? It is equal to the current in Y and Z. No, it's larger because it splits into the branches. It is less than either current Y and Z. No, it must be larger. It is equal to the sum of Y and Z. That is correct. So the answer is C. Question 29 says a student connects the circuit as shown. Which switches must be closed for the bell to ring without lighting the lamp? So we need the current to move in this direction only without passing through the lamp. So switch 1 must be closed, switch 2 must be open, so the current does not pass through the lamp, and switch 4 must be open, so it does not short circuit. Switch 3 must be closed, so the bell rings, so the current passes through the bell. So it's only 1 and 3, so the answer is B. Question 30 says the diagram shows an AC generator. The graph shows the potential difference between points X and Y plotted against time. A positive value of potential difference indicates that X is more positive than Y. Which diagram shows the position of the coil at point P on the graph? It's not B and it's not D, since the current should be 0 at these points. So for Y to X, the current should be moving in this direction, not from X to Y, since Y would be more positive than X. So the current should be coming from this point, moving in this direction in the coil. Or for C, it should be coming from this point. So the current should be going in this direction in the coil to go from Y to X. But in the original diagram, we have the north and south poles like this. Using the right hand rule, we have if the magnetic field is pointing to the right from north to south, and if a wire is moving downwards, the current would be out of the page. So for the current moving downwards, in A, the current is going into the page, so it's not A. In C, the wire that is moving downwards has a current going out of the page, so the answer is C. Question 31 says an electron moves into a uniform magnetic field. The arrow shows the initial direction of the motion of the electron. The direction of the magnetic field is into the plane of the page, so we have the direction of the magnetic field, and the current is always opposite to any negatively charged particle, so the current is to the left. In which direction does a force act on the electron when it enters the magnetic field? So we use Fleming's left-hand rule for that, with the current pointing to the left and the index finger, which is the magnetic field, pointing into the page. The thumb will be pointing downwards, so it's not into the page, it's not out of the page, toward the bottom of the page, so the answer is C. Question 32 says which statement about a transformer is correct? There is an alternating current in the iron core. No. An alternating current in the iron core. Also no. An alternating current in the primary coil induces a direct current in the secondary coil. Not direct current. Alternating current in primary coil induces alternating voltage across the secondary coil. That is the correct answer. Question 33 says how are positive and negative ions formed from atoms? So for positive ion, we need to remove electrons. So not adding positive or removing positive. We need to move electrons. So for positive, we remove an electron. For negative, we add an electron. So the answer is C. Question 34 says a nucleus of element X is represented as X, 56, and 26. which is an isotope of element X? We must have the same proton number, so the answer is B. Question 35 says a radioactive source is placed near a detector connected to a counter. 210 counts are recorded by the counter in 3 minutes. The background count rate is 20 counts per minute. What is the correct count rate in counts per minute for the radioactive source? So in 3 minutes, we would have counted 3 times this value for background. So the actual background for the reading of 210 is 20 multiplied by 3, which is 60. So the actual value in 3 minutes is 210 minus 60, which is equal to 150. But this is for 3 minutes, but the reading is count per minute. So for 1 minute, we divide that by 3. So we get 50 counts per minute. Question 36 says a background count rate measured by a radiation detector or counter is 40 counts per minute. With the counter close to a radioactive source, the counter reading is 960 counts per minute. The half-life of the source is 20 minutes. What is the counter reading 1 hour later? 1 hour later, that's 60 minutes. If we divide 60 by 20, we get 3 half-lives. First step, we remove the background from the reading. So we subtract 960 minus 40. We get 920. Then we divide that by 2 3 times, since we have 3 half-lives. 920 divided by 2 is 460. We divide that by 2, we get 230. We divide that by 2, we get 115. The last step, we must add the background again. So we add 40 again to the reading. So we get 155 counts per minute. Question 37 says, which planet in our solar system is nearest to the sun? That would be Mercury. And what is the nature of the planet? It is not gaseous, it's rocky. So the answer is A. Question 38 says, a space station orbits the Earth at a distance of 7,000 kilometers from the Earth's center. It makes 15 orbits in every 24-hour period. What is the speed of the space station in its orbit? And the answer is required in kilometers per hour. So we have the distance is a circumference, which is 2 pi r, but it makes 15 circumferences every 24 hours. So we multiply that by 15, then we divide by the time in hours, which is 24. That gives an answer of 27,500. So the nearest one is 27,000 kilometers per hour. Question 39 says, which nuclear reaction powers a stable star? It's not nuclear fission, it's fusion, but not krypton nucleus. It is hydrogen nuclei producing helium. So the answer is D. Question 40 says, which stages in the life cycle of a star are listed in order that they occur? Interstellar dust cloud, that's nebula, into a stable star, then protostar. No, these should be reversed. Protostar, then red giant, then stable star. These should be reversed. Red giant, white dwarf, then protostar. No, protostar, then stable star, then red giant. So it's not C, it's not B, it's not A. So the answer is D. Stable star, then red giant, then white dwarf. So this was the end of the exam. I hope you enjoyed this video and it was useful to you. And I will see you in another video.